Who's excited for word problem day? Okay, so I know nobody likes word problems. These ones, though, are probably going to be the easier types because you're going to get triangles every time. And then you're just using the trick stuff. You, I guarantee, will see these on ACT, SATs. They'll always do that kind of stuff. So these are going to have different things called angle of depression, angle of elevation. Okay, so down here it says if the line is below the horizontal, so you're going to have a horizontal part and then a 90-degree part. So it might go that way and it might go this way. So if it's an angle of depression, just like when you're depressed, you're down. Angle of depression is when you're looking down. Angle of elevation is when you're lifted up. So you'd be looking up for the angle of elevation. Those are going to kind of be the two things that are in every single problem. So I've got a bunch of problems to share with you. Let's try them out. Okay, in mine, they're going to give you these. Obviously, I'm not going to give you the pictures and everything. So you'll just basically be getting the word problems, make your own picture. But every time, just make yourself a right triangle because all of these are going to have right triangles in them. Okay, so in this one, here's my right triangle right here. It says a flagpole. This flagpole casts a shadow, a 60-foot shadow. Anytime you see the word shadow, shadows are always on the ground. When you look at your shadow is just on the ground. It never moves. It starts at your toes, on your feet, and it goes out on the ground. So if you see shadow, 100% of the time, that is going to be on the ground. Okay, so the shadow on the ground and the angle of elevation of the sun is 35 degrees. So here's the sun rising up over here, and the angle of elevation is going to be 35 degrees. So it's elevation, which means going up. So that's why this is the 35. This one down over here is looking down. So it says find the height of the flagpole. Height is this one here missing. Okay, so just make yourself a triangle, and then you don't have to draw a picture, but obviously the height is going to be this one right here. Okay, so just like before, just like the past couple days we've been doing, there's your angle. I've got hypotenuse, I've got adjacent, and I've got opposite. So it's exactly like we were doing before. You just have to set the problem up. So in this case, you've got opposite and adjacent. That is tangent of 35. And you're going to do opposite over adjacent. So h over 60. So we're going to multiply both sides by 60 to finish solving. Oops, come back. All right, now, again, don't forget to put your calculator because this is what your calculator will look like when you get things cleared. So go into mode. My degree needs to be highlighted. So go to your degree, hit enter. Okay, so now I've got 60 times the tangent of 35, and that is going to give me about 40.0. So it doesn't say it around. If it doesn't say, I'd always do to the nearest tenth. So in this one, I'm going to do 40.0. And don't forget in the word problems, you always need a word with your answer. So height of the flagpole, they were measuring it in feet. So all word problems get a word with their answers. Okay, same thing over here, angle of elevation. So here's my triangle. Again, you don't have to make the building, just make yourself a triangle. Angle of elevation is the one on the bottom, so 53 degrees. And then the building is 60 feet high. So we're going to look how far the point is on the street to the foot of the building. Here's another word that means the bottom. So when you see shadow, it's on the bottom. When you see foot of something, the foot of something is always the bottom. So leave yourself a note for that. If you see the word foot, bottom. It means the bottom of something. Okay, so how far is the point of the street to the foot of the building? They're asking you for this right here. Okay, so just like before, we're solving. So I've got 53, and that makes this the hypotenuse, the adjacent, and the opposite. Okay, so the thing that has nothing is the hypotenuse. So I've got opposite and adjacent. Again, tangent. And I picked the 53. I know that there's you can find the other angles, but I'm just going to use this one. So this is opposite over the adjacent. Swap these and then plug that in your calculator. So 60 divided by the tangent of 53. And that's going to give you about 45.2. And then again, go back in your problem, find what they measured in. So that's going to be feet. Okay, if it's an angle, obviously it'll be degrees. Okay, next, Next, I want to talk about the angle of depression. So when they say angle of depression, so this is saying top of the building. Here's, so I just made the triangle bright and yellow so you can see what we're talking about. So just make yourself a triangle, make a right angle. We're going from the top of the building to the ground is 10 meters tall. So this over here is 10 right there. And then it says in the angle of depression from the top of the building, so now we're looking down, is 22 degrees. Now what's weird is if you're doing the angle of depression, you'd be doing this one, which is outside of the triangle. So remember, if you have parallel lines like this and a transversal, then these are alternate interiors. So here's a fun fact. 100% of the time, you can make this exact triangle that I have right here for every single one of these word problems. Whatever your angle is, whether it says depression or elevation, 100% of the time will go right there. So every time, make this exact same triangle. Whatever they say for your angle, depression, elevation, doesn't make a difference. You put it there. You can use that triangle every single problem. Okay? You just have to figure out what they're asking for. So now it says, how long should the wire be? So the wire, they said, reaches them from the top of the building to a point on the ground. So they're asking you for this side. Okay, that's all you have to figure out. So make your triangle just like this every time. Label the angle they give you, and then you just have to figure out what two sides are what. That's the only thing you really need to do. The rest is just the stuff we've been doing all week. So this is my hypotenuse, this is my opposite, and my adjacent, and there is no adjacent. So I'm using sine of 22, which is opposite over hypotenuse. Okay, and by now you guys know how to solve, so you would just swap and you would do 10 over the sine of 22. So for time savers, I'm not going to plug it in the calculator. Just make sure that you put meters with your answer. Just go back up and find what they used. Okay, so regardless, 100% of the time, depression, elevation makes no difference. You just want that angle in there. Okay, so top of the lighthouse, height is 100 feet. So here's my 100-foot lighthouse. And then it says angle of depression is 55, which means this will be 55 because they're alternate interiors. So like I said, regardless if it says elevation or depression, it's always the angle on the bottom with your 90-degree angle. Okay, and then it says how far from the foot. There's that word again. When you see foot, think of your foot. It's on the bottom. So foot of the lighthouse to the sailboat is what we're looking for. Okay, so in that case, we have 100 feet. That is my, this is my hypotenuse. This is my opposite, and this is my adjacent. Okay, so I need adjacent and opposite. So that's going to be tangent again. And we're going to do the opposite over the adjacent. So swap those, and all you have to do is 100 divided by the tangent of 55. Okay, over here, this one is a little bit tougher. So I actually have a couple, I put the triangles in there. This would be the hardest that you see, and I honestly haven't seen them that often. So now it says, here's my person on the edge. It says, we're looking at the lamppost with an angle of elevation. So from my sight, this is my sight, my flat line of sight vision. So elevation looking up at the top is 12 degrees. And then if we're looking down, this is still my straight vision of sight. So looking down is going to give me 7 degrees, okay, for my depression. Then it says the person's eye level is 152 centimeters. So that's how tall the guy is. They want to find the width of the canal. Okay, so first, I'm going to pull this triangle up, maybe. All right, so I'm going to pull this triangle up so you can see what we're talking about, because this is going to be my first triangle right here. This is what's going to help me. Okay, so in this case, let me get a color. All right, in this case, here's my 90-degree angle. They're asking me for the width of the canal, which is this right here. I've got my 152 over there. And then my angle of depression was 7 degrees. So that means this is 7. 100% of the time, your triangle, whatever angle is on the bottom with the 90-degree angle, that is your angle. Okay, so in this case, I've got opposite and adjacent. So I'm going to do tangent. So tangent of 7 degrees right there is equal to the opposite over the adjacent. So if you just swap those, that'll give you part A. Now, if I'm doing part B, I'll do it in a different color. Let me move this stuff out of the way. So with part B says find the height of the lamppost. So we're looking at this stuff over here. Now, to be able to find that, I've got to do a few things. First, I'm going to use this right here. That's going to give me part of the height. It's not going to give me the whole height. So I've got two different triangles I've got to do for this one. It's kind of annoying. So it gives me the 12 degrees. I already got the 12 degrees. And I'm looking for this. I've also got this. I just found that out in part A because this is the same as this right here. It is the width of the canal. So I actually need to figure that out. 152 over tangent of 7. So that's going to give me about 1237. We'll call it 1238 just to be easier. Okay, so 1238 centimeters. So now what they're asking me to do is find this over here, which is the opposite and adjacent. Oh, tangent of 12, sorry, is equal to the opposite over the adjacent, 1250. Is that 1258? Yes. Okay. Oh, 30. Okay, so if you times 1238 times the tangent of 12, that's going to give you this part right here. That's going to give you this. Now, the other thing is I need to do this triangle as well because I need to find that other chunk. So for this one, maybe if I can just, okay, there we go. So I can just use this triangle. So for this triangle right here, I can't move the other one, but it's fine. So for this triangle right here, I've got this 7-degree angle. I've got the 90 degree. Here's the 90 degrees. Here's the 7. They already have it set up for you. So they already gave me this angle. And then we're looking for this one over here. Okay, so I've got this part right here, which is 1238. And I've got my angle. So across is my opposite. My hypotenuse is missing. And my adjacent. So tangent is going to be opposite over adjacent. And then you're just going to multiply by 1238 and get whatever y is. And then you'll just add them. So whatever you get from the blue answer, whatever you get from the green answer, you add them up to get the total. You probably will not see one this difficult. I just wanted to show you in case you do. So sometimes you got to take multiple pieces, especially when they give you height. But these are going to be, the easier ones are going to be the ones you mostly see. I just wanted to give some of you that need a challenge in the class and have like 100, what a difficult one would look like. Okay, these will be more normal. So I think I got 2 more. Yeah, 2 more and that's it. Okay, so I did 2 more like you're going to see on your homework. You're not going to get a triangle. So you just make the same triangle every single time. Make yourself a 90-degree angle and let's figure out what's what. So I've got a plane approaching the runway. It says the pilot must begin a 3% descent. So we're looking at 3 degrees. That's my angle of depression. Regardless whether it's depression or elevation, it's always going to be at the bottom with your 90. So there's your 3 degrees. My height of the plane, height is always going to be the vertical one. So that's 2714. And then the airport, so they said that the height is 2714 above sea level. This is a little tricky in here. And then it says the airport, which is right here, is 1,007 feet above sea level. So that is important because what you're going to have to do to find the height of the plane is you're going to have to find what it is above sea level. So I'm going to have to subtract that. So that's going to give me 1,707. So I actually had to change my height for that. Oops. Let me get this out of the way. Okay. So that's going to give me my actual height. Sometimes they throw little tricky things in there like that. So this is going to be 1,707. That's going to be my height from sea level to the plane. Okay, so now let's see, I've got to the nearest 1/10 of a mile, how far from the runway is the airplane? So we're looking for this right here. Okay, and then that's all we got. That's all we need. So I've got hypotenuse, and this is opposite. So I'm going to be using sine of 3 is equal to the opposite over the hypotenuse. So I'm going to swap these and type that in my calculator, and that's going to give me what I'm looking for. Okay, so you just have to watch out for something small, but every time just make yourself a triangle. So I did it here too. I just made a triangle. I've got my right angle in there. And it says from the top of a lighthouse 60 meters high. So if you're talking about height, that's going to be the tall one. And then the base is at sea level. And it says the angle depression, which is irrelevant. It doesn't matter because it's always going to be the one on the bottom with that 90-degree angle. So 15 degrees. What's the distance from the boat to the foot? This is always the bottom. So that's it. Okay. So I've got the opposite. I've got the adjacent. That means I'm using tangent. And then you're just swapping. So I'm going to be doing 60 over the tangent of 15 to get whatever my answer is. Okay. So